Hello friends. So let us study about regression testing. Today the topic is testing technique. So in testing technique we're going to study the various type of testing. Yes. Some of the testing techniques or the types you must have studied in a software engineering. But now we're going to study in an elaborative manner, like why we need to do it, how we need to do it, or what are the tools that are required to need do it. So first is regression testing. I have not made in a sequence like what test should come first, followed by the other, and so on. But let us see one by one. You will get an idea when to use, how to use, why to use. Because maybe in software testing, maybe in software engineering, maybe in a software design, the one thing is more important. Of course, I've been telling you for the three lectures, I've been telling you the requirement is the highest priority and that is considered in your development, in your testing. In case of a change of your requirement, the entire thing gets changed, correct? But before we begin with testing, in case the word change comes, and this change going to affect everything from your communication, from your requirements, from your designing, from your implementing, and from your testing. All the five phases gets changed. How they get changed? Or what are the what are the reflectives happens when the things gets changed? I'm not talking, once again I'm repeating the statement, I'm not talking in terms of software engineering, I'm talking in terms of change in software testing. So first thing, when the change encounters, so what happens in a testing? Yes, first is regression testing. As I told you, I have not made any sequence, but I will let you know when, why, and how, where to use this kind of testing. So, in case of changes happens, correct. Now, if my requirements gets changed and my system is developed, even tested, what happens is, so regression testing. The main concept is the first thing. Okay, forget about the change. I hope you are familiar with the words like defect, error, mistake, and so on. So, normally in software testing, we use the word defect. Correct. So, what is defect? A module which is not functioning as we expected. The first thing. And second, when I propose the module to work, like addition of two numbers, but if it is addition of two numbers, irrespective of addition, it's giving me something illogical output or not having any meaning of that output. This can happen, and this sometimes this and we encounter this kind of errors which we thought, oh, this is output, but this is something else. Okay, so first we begins with the regression testing and how the regression testing is done. Why? So first thing is the main idea. Let us talk about the regression testing. The main idea in regression testing is to verify that even the unchanged portion, there is no defect has been encountered or introduced. Sometimes for a software testing, software tester itself introduces some defects to find out that even though if there is a change, how the system will work. Remember, we will not touch the actual code. Whatever the developers have given to us as a software tester, we will not touch the code. In fact, we will make a replica of that code. And same thing, same files, binary files, exe file, whatever is needed, we'll make that one. We will not hamper the actual one, because in case if I change some statement, if I change the module, I want to know what happens is. So what happens is, I don't want to hamper the actual code, the real code. I will make the mirror image, or I will do the coding, same coding. I'll do it irrespective of time. Of course, I have to see my deadline. What I'll do is I'll make the replica and I will make some changes. I will test that code whether to see whether the actual my code is working or not. Even some errors are introduced, it's showing me error or it's giving me still output. Because what happens is, in actual life, in real life, if I define some output, like say this remote control, talk about this remote control. If I press on, my AC will get on, correct? But if I power off, this is the same button like on and off. But if there are two buttons, if even I'm pressing off button, still the AC is working on, functioning as on. So is this a defect? Yes, this is a defect I found in my system. So let's talk about the regression testing. Listen, I'm not diverting from my topic, but sometimes you will ask or you will wonder what happens if we make changes in the actual code. What happens if test itself introduce some errors to the code? So these are the facts that I mentioned you. Now, the main idea is the main idea about regression testing is to see whether the actual code is working as expected. So it's unchanged portion of a system due to the changes made elsewhere. I want to see that particular module is working irrespective that a defect has been introduced to the entire code. So as a result, the next point is written over here. As a result of this, one of four scenarios can occur for each fix. Then what happens is the report defect is fixed first thing, even if I found that there is a defective. Then, in spite of making an effort, the report defect cannot be fixed. I don't know why it's not been fixing. I need to talk to developer because I'll not be fixing. The code fix or the code repair work will be done by developer. I will not do. As a software tester, I will not touch the code. Then a report defect has been fixed as a reported. Now, as a software tester, I have detected the number of testing errors or defects. So I will list out. See, these are the number of the defects I found. Then now I will give it to the developer on some note. I will make a some note. Some note in what sense? There is a form given, there is an app template. Now in that template, I have to fill that template that what error has encountered, what defect found. Now defect life cycle is different. I will tell you in the later section what is actual defect and how the defect is being resolved. So for this topic, we need to talk about little about. I'm just briefing you the concept of the defect because it's not so easy that these are the errors and I'm giving to the developer. No, there is some format, there is some protocol. Like there is a template, I have to fill out the template, and according to the template, I need to understand those information and give to the developer. Then developer will see again. There is a template for the developer to go through it, and developer will touch and fix those code. Because if there is no such protocol, that developer will say, oh, I'm not there, I will not do this because I'm not in charge, I'm not the one who developed this. No, there is a protocol for all these things. There is a format, like there is a format for your requirement collection, like SRS template. For your testing, the test cases, there is a format to make your test cases. So similar, there is a format for everything in software testing, in software designing, and software engineering. You always get a format for this, a protocol or a prototype. So now the report defect which has not been fixed in spite of an effort, sometimes it has been seen as it was keep failing. Now what happens if the developer has sent me the code, corrected code, and now it's working fine, but later I found that again that same code is failing again and again. So what I'll do is, again I will give it to developer and I will ask developer, please fix this code. So these are the number of things that may happen or that might be encountered. Yes, this can happen. Some of it that reported defects have been fixed. Sometimes it has been fixed, sometimes it has not. Sometimes it works like it has fixed, but it will not give the output as expected. And sometimes, like the defect, you will not see the defect anywhere, but you will still get the output. So this is some kind of intermediate error. Then the reported defect which not been fixed in spite of effort, and sometimes it is used as being failing. And so these are the features of it. So regression testing in another level, is another level of testing that is performed throughout the life cycle of a system. Now what happens is regression testing is done from requirements till software testing. It's because that if any part is changed, if any part is changed or any phases during your product life cycle has changed, no, it has to undergo a regression testing to make sure that whatever the customer expected, whatever the customer has demanded, it is available or not, it has met that same requirements or not, because in the end the requirements matter, in the end customer expectations matter. I repeat again, this is not software engineering we are talking about, because in software engineering, whatever it is, software engineering, software testing, software design, software architecture, the most important part is your requirement. Without requirement, your base is nothing. Now, the regression testing is performed whenever a component of the system is modified. This sentence is very important because, as I said, throughout your product lifecycle, regression testing has to be done to ensure that your requirements, which has been changed, whether the one component has changed, two components has changed, or entire components has changed, feature or the functions of the components has changed, your regression should make sure that the customer expectations has met whatever is expected. Later, the key idea in regression testing is to ascertain that the modification has not introduced to any fault parts. See, what happens is that module A, for example, is the addition of two numbers. But later, what happens is I found the false, but that portion was not modified. For example, as I said, suppose there is a add module, like there are four operators: add, subtract, division, multiplications, and for add module there were no changes occurred, no changes in the module happened, no changes, no modification, nothing was introduced. But I found a fault inside it. How? I did not change anything. This can happen. This may happen. Now, in regression testing, tests are selected. Okay. Now, what type of things are come here? What happens in regression testing? Like testing test, what are the tests to be selected. Now in regression testing, you will perform like unit testing, module and integration testing, system testing. Different types of testing is performed inside the regression testing, because this regression testing is the whole of the testing, because it occurs whenever the changes have done or the modification is introduced in the system. So, from the existing pool of test cases to ensure that nothing is broken. So, what happens is if the changes are done, it's not that my system is entirely built and now the change has done this is also one case, but another case is like when my product life cycle is evolving or developing, or suddenly there is a change introduced inside that code. So what happens, it becomes in another version. So without tempering the another version, I have to execute certain tests to prove that the system is working what is expected, neither is not what not is expected. If I'm not expecting my system to work as on and off, or suppose in any say any functions, right, like clicking button or pressing the button on, off, pause, instead of this operation, if my system is behaving something abnormal, then that is risky, that I have to give to developer and ask what function is this is not been discussed yet, because even the tester, they also have the requirement SRS format, they have the TRS, I mean test case, everything they have before they go for the testing, undergo for the testing. So now regression testing is an expensive process, of course, because it starts from first from your requirement till the end. So it is one of your expensive process. It's required your resource, your cost, everything, people, and so on. So it is desirable to select a subset of the test cases. Now instead of selecting all those test cases, all those tests, so what if only the few which is required. Now I don't want that entire system to be tested. I want just one model. So specifically related to the module, I require those test cases. then regression test cases at different software level in the software testing. So, so regression testing can be done at level of unit testing, integration testing, system testing, and acceptance testing. Acceptance testing we'll see in the last part. So first we'll see uh, about the unit testing, but let me finish with the regression testing. So now the question is, like, a key question is, how many and which test cases should be selected. That's the first question. Now you will see that even if you're carrying working on regression testing, you will find that pool of test cases. Even there is a test case database and you don't know how to select, I mean what to select. How many of you will select the test cases? How many you will put these test cases under test to verify that this module are working accordingly what customer wanted, what customer needs? But you might, or as a software tester, you might get confused. So you have to think and select that, okay, module 1 has changed. Let me pick out the module 1 test cases. Module 2 has detected some fault, and it has undergone changes. Let me pick up the test cases of module 2. From where? From test case database. So they selected test case which are more likely to uncover new faults. Because why we need to do the changes retesting, so that in case new faults or new defects can uncover or we can find out. Now these are the validation activities like unit testing, integration testing, function testing, system testing, and acceptance testing. So first we'll see sorry, unit testing. Now unit testing, that means only a single, what is this, only one single pin, correct? If I say this two, the what could be this will be the two pins, but currently it is one, that means one unit. uh, One unit means a one piece of code, only one piece, one single code. Suppose if I again I'm talking about the example, like if we are talking of like addition calculator code, suppose, and there are lots of buttons. So on the button click you make a functions, you create a functions like press 1, you double click on the button and you write the code like press 1 on your text. So text is equal to in Visual Basic or in whatever the code you want, whatever language you prefer to do, correct? So in all these modules there could be 10 or 20 buttons, suppose, and we don't want to test one, I mean 10, 20 at a time. I just want to need or pick only one module. Say I will choose only plus sign module. Now what happened in addition module, let us say addition module, what I'll do is I will just choose the addition module. Only pick up those additional. I will not hamper the code. Remember, I will not touch the code. I will just look at the code. I will make that addition code and I will perform testing on it. I will not do the testing on the real the code. I will not hamper the real code. What I'll do is I will just pick up. I will put it to the tool like JUnit, and what I'll do is because unit testing we use a JUnit tool, and in the tool we'll talk about the tool in the later section because there is a software tools topic is there. So I will not tell you about the tools and all. I'm just telling about the unit testing. I'll let you know, but otherwise I'll talk about how the testing is done. So just put into that and you just change some code, some piece, make it pieces, bits and pieces, make it, and try to execute. See that your code, even if it change, is giving you the expected output or it's giving you actual output, correct? If it is giving you if it is giving you expected output, what you expected your output should come and what it has come, is it same? No, that means your test has failed. That means you have changed your code. Now original code, test your original code as it is. So for this unit testing, it is just only one piece of code. Yes, you will ask me, ma'am, if there are 200, oh sorry, not 200, but if there are 50 modules, we have to change, I mean we have to test one by one. Yes, for the 50 modules it will take time. Isolate from everything, isolate that module, pick up one module, test it. You just see that it meets your expected output and see the actual output and expected output, compare it. If both are same, your test is pass, otherwise your test is fail. In case of test is fail, report to the developer. correct? Because you know what could be the output. You have got every sort of documentation available to you. You need to understand how the code works, what is the code about, or what is the product about, and then test one by one. Yes, we are just talking in a very simple manner, but when it comes for the testing, it's a huge code, it's a very big code. It's not just only addition or subtraction. It's just while explaining, I'm explaining this code. Then okay, again continue with the unit testing. Then, second, during unit testing, it is desirable to verify that each distant executions of program unit produces the expected result. That's what I explained earlier. That even if you isolate your piece of code, just isolate it piece of code and execute it. You just compare it with the expected result. It is the same or it is different. In case if you in the defect is found in unit testing, they're internal to the software development group. Yes, that's what I said. That's the same thing is mentioned over here. That means you need to report to the software development group, and they are not reported by personal hierarchy to counted in a quality measurement metrics, right? These we will talk about measurement metrics in a afterwards after studying the software tools, because it measures the quality, like how much time it has been wasted just because we in the end we expect a good quality. So in software testing we won't say this is a good quality. This is when you buy some hardware material, you just say, oh, this is fine quality, this is good quality, this is bad quality, this brand is of good quality. So we are not talking about a good, bad, and all. There are certain values or there are certain points that we need to compare our product with, and later on will come up so that our product is really good to is easy to use, is it portability, maintainability, testability, and so on. Correct. So let's talk about right now if my code has some errors, like as a software tester, I've tested my code and I've given to and I found certain faults, which means my expected result was negative. What I did the formattation, I did my documentation, I sent to developer software development group, and later on and during this procedure it will be not be counted as the quality, because this is a rework. How the rework is done, the code is itself giving me the errors. That means, okay, developer has executed. Now see what happens is, when I run the code, it has given me the output. So this is not the way to execute your code. Your developer will not be a tester. At times, developer become a tester, but not every time. Your developer will be a different one. Your tester will be different work. Now, at times in your project, when you do your project, you will be a designer, you will be a developer, you will be a tester, you will be your quality assurance people, team, and so on, but you will play all sorts of role. But when it comes to developing a product, in reality, not in reality but in industry, what happens is there are the teams who will work under one phase. As project, as when you do your final year project, you will handle all these phases in one month. I think you have just made up a timetable and so on. But this rework, so what I'm talking about, the rework, like the error, you have encountered error or you have encountered that defect, right? Now it's work and you need to do the rework. It's like you prepare the documentation, you have given to the development team, and development team is looking after it. Till then you will work with different modules, and in case again the error comes, again it is notified to them, to whom, to the development teams, and so on, because this is a I mean it's a lengthy procedure, and this will be not counted because this is entire thing is your rework again and again and again, till the you are not getting your proper output, not output what customer wants, because in the end it depends all your customer. If customer is giving you such things like, no, it's not working what I expected, or it's giving you some kind of remark, then everything is in vain. Then, okay, now unit testing are of two types. The unit testing consists of static and one is dynamic. What is static? Okay, static is about the code review procedure. Okay, this static unit testing, I guess we finished in the last lecture. Let us revise one more time, that this is a review procedure, in that you have an author, you have an inspector, you have a people who will go through your code, and in case of any changes they will ask you. So here in this static unit testing, the actual errors, or as written here, defect minimization process can help to detect problems that are common to software development. Now, very few like software development problems can be encountered by looking at the code. And who will look at the code? Who they are? The senior people, the senior team member, or the senior management will look into the code, because one who knows the language, the programming language, the code very well, who understand the code very well. If suppose if now I'm learning PHP, for example, I'm learning Python, and someone asks me from my team, ki ma'am, please come and review for the Python code. I will surprise, because I first and foremost, if I don't know the syntax, the semantic of Python language, how will I execute those code orally? This is a simple language I'm explaining you. Otherwise, this is a technical thing, because if I explain it technical, it will just bounce. So try to understand that even if you know code, if you understand programming language, you can break through this. But this is time consuming process, the first thing. And second thing, that you have to find out yourself, you have to debug and execute it orally. Now in dynamic testing, a program actually of one unit is tested, is observed, and find out that it's been it's been according to the customer use or not. So it may be noted that static unit testing is not an alternative. Say static is different, dynamics is different, but that is not the alternative of static to dynamic. It's like, oh, I finished static, so why we prefer dynamic? Or it's like, it's not like understanding. Since my team has done the dynamic unit testing, you know, no need to go static unit testing. No, it depends on the different teams. Static unit testing team is different, dynamic unit testing team is different. In case of its go, it can go through in a both ways. Then you have a system integration testing. Now what happens is, in a unit testing, that means one piece, a single piece of module was tested. Now in system integration, that means several modules, two modules or three modules are interfaced with each other. How they are interfaced with each other? They are integrated. Now what actually they mean by integrated? So, a module, now what is module? You will ask, what is module? All of you know, since we are in a technical field, we code, we write code, we make code. So, what is module? A module can be a function, a subroutine, a procedure, or a class, or a collection of those basic elements that put together and perform certain function. That is function. For a high level resource, a class, if you're using your object oriented programming concept, you use like a class or a collections. Of course, I'm sorry, I'm learning a Python, so I don't know which function they use Python. Okay, so a system, so normally what is the module? It's a collection of a system, that is a collection of modules, and they're interrelated. So remember, if you remember your software engineering subject, you will see that modules should be tightly loosely coupled or high cohesive. Correct? That means they should have interconnection should be minimum, because if one module consists of error, it will prone or it will propagate to another module. So they are loosely coupled. Correct? One more thing that you will say, that ma'am always keeps telling about software engineering. See, certain things, certain terms are software engineering, software testing, software developing, software architecture are same concept. So they will keep coming up, and we'll have to according to the terminology, we need to understand those things. Correct? Now, a system, that is a collection of a module interconnected in a certain way to accomplish a tangible objective, right? Now, suppose, as I said, calculator. So, for the calculator, there would be a modules like digits module, there could be modules like operations module, operators, and equal to. So, there are certain modules are defined, but later these functions, they have sub functions also, like 1, 2, 3, 4. These are the operations. When I click on button 1, the button 1 should be displayed on my text box, and so on. So how you will do your system testing? Let's see. The first thing, okay, first we'll study the theory, then we'll study about how to do it. the importance, the why you feel like integration testing is so important. Why you feel after doing the unit testing, you will ask me, ma'am, why there is need to do system testing? I've done unit testing, checked my each and every piece of code, and I've executed. I found that there's no error and it is according to the expected output, expected result has come. Okay, so why do you need to interface then? Yes, you need to interface code because we need to check the entire piece of code. We don't want only one single piece to execute. Correct? We want certain, like we want two modules or three modules in some hierarchy to conclude, to find out that if these modules club together, executed together, will they perform the same operation or they will give me some defects, some errors, and so on. Okay, so what is the importance? So let us talk about the importance. Like different models are generally created by a group of different developers. Yes, so what happened, let's talk about the developing phase. Like if you know your software models, so there has a rad, there's a water cycle model, there is prototype model, and so on. So in if that if that team, if team A and team B has followed the rad model procedure, that means the design will perform by one team and the implementation will perform by another team. And later on, those implementation teams, they will club their code together. They will club all their models because the models are being distributed. Or forget about the software development process. Suppose if I am your team leader and I have made the team, like team A will carry on the module digits, they will make the module digits. If team B, they will make the module operations implementation, and in PNC they will do the equal sign, right? I've distributed these three modules and later on I will collect these modules together, and as a team leader I will try to execute, and these things, while during the execution of all modules together, errors or some defects will be coming out. Now, the developers may be working at different sites. Of course, there are different sites. Like one is working in Mumbai, one is working in Bangalore. Suppose there are two different teams, like in different places. And when I asked them, come on, it's time to give, is your crossed your deadline now. You have to give me your codes. As a team leader or as a senior faculty, I will just try to merge it. And when I merge and I saw, oh no, I will not do this testing and all. This is given to the testing team. So there is some errors like interface error between the modules, because this first thing, if the program is short, if the modules are very short, okay, the one man has created. But if if the code is lengthy, there are several number of modules, so that means this has been broken up into teams and the modules has been distributed, and later when they are interface, they will give me my errors. Now, so unit testing of this individual module is carried out in a controlled environment. So again, the same thing happens. The same thing happens in what way? The real code is not touched, hampered, or tempered. The real code, actual code is as it is. I'll make a replica of the code, which means I'll create the test drivers and stubs. So what are the stubs? Stubs is a dummy module. As I'm telling you, replica means stubs are the dummy module which will merely return me predefined values. And if the other modules under unit test invoke several other modules, then several other modules are more prone than the other modules because of the inherent complexity. Again, the complexity. Always remember that your complexity should be at minimal level. It should not create a highest complexity. The more complicated or more high complicated complexity, like if the complexity increases, that means the budget or resource, everything is increases. Try to keep it at minimum level. Every phase talks about how your system complexity looks like. The modules are more error prone than the other modules. So it is essential to identify which module is causing the errors. Then you have a different types of interface. What is the different types of interface? Like two or three modules are being interfaced, but how they are interfaced? Through procedure call interface or shared memory interface or message passing interface. Now these are the common coding. In a coding way you use this through a function call, like I called a module, B is calling a module, or a shared memory interface in your operating system, message passing interface as a in operating system it happens. Then while putting them together, the following interface error might encounter. Suppose what happens is, what happens if all these modules comes together during your interfacing? The first thing is construction. That means how they are connected. Inadequate functionality, location of functionality inside the cloud class, or whether it is private. If it's talking about object oriented, so the class has a visible scope of members. Scope of members, like are they public, are they private, or they are protected. So if I'm calling class A, if I'm calling a class inside, suppose I'm calling class B. Okay, my class is A, I'm calling class B properties. So in case if it is a private, I cannot make a call. So that's a error given. Changes in functionality, added functionality, and interface if I'm using a wrong interface, and so on. And interface is not understand, misunderstanding of interface. Data structure alteration, if I'm not use a proper data structure to address my values, my variables, and so on. So because of testing, you need to understand the basic level of your coding, of your language, and so on. And initialization of or value errors. If I wrote like integer a is equal to 5, and there I'm doing the character like a's bracket, I'm putting some values. That doesn't make any sense, because I'm defining integer and I'm writing in a character. So that will give me an error. Now, system integration testing technique is done in so many ways. In how many ways? 5 ways. Yes. So first is uh, top down. First is incremental testing, then top down, bottom up, sandwich, and big bang testing. Now, well, let us see one by one. Now, incremental testing. So, incremental testing is the number of testing integration test cycles and total integration time are determined. So how actually this is done? See, system integration test integration cycle. So of course, each and every test phase has their own cycle, and they are. It's like mm, the first thing, number of module. First, number of modules in the system. Then the complexity. How is the complexity? Then you have relative complexity of the interfaces between the modules. That means the number of system integration test cycle and the total integration time parameters. They determine how many modules are being used and how what are the complexities between them. Are the complexities are high or low? This should not cost the system, because ultimately this will cost your customers. One customers will later complain. So we need to keep the complexity low. Relative complexity of interfaces between the module. Then number of modules needed to be clustered together in each test cycle. Whether the modules to be integrated have been tested before. Yes, because in a later part, first I have done my unit testing. Okay. Now when they are integrated together, have they been tested before as a single unit, and what is the turnaround time for each test, like test, debug, fix cycle? Because these factors they will affect in the later part. Now this is my top down approach. Now you see this 1, 2, 3, 4, 5, 6. These are in a square bracket, I mean square box. In a box they are modules. So let us say module 1, module 2, module 3, module 4, module 5, module 6, and module 7. Correct. And now how they are being addressed, how they will interface. Let us see. Now module 1 is interface with module 2, At first level 1, consider module 1 is interface in um, with module 3. Again, module 1 is interface with module 4. How they are interface, how they are integrated? They are integrated in a bi-directional way. Like module 2 will interface with module 1 and module 1 will interface with module 2. Correct? This is a top-down from top to down approach. Right? Now, then we have module again. This is a first step. Okay, we'll just say interface tested. So this is steps and interface tested. Then in the fourth step, so 1, 2, module 1, module 2 and module 5 is tested. Later part module 1, module 3 and module 6 is tested. Then module 1, module 4 and module 7 is tested. See, module 1 to 5 in the fourth step, fifth step is 136 and 6 is 147, correct? And later, the last stage is 125, 136, 147. So in this way, the top-down approach is executed. See how it is done. Then later, this interface tested you have seen. Now we'll go to the order of the testing of the interface. Now let's see bottom up. Now in bottom up is my 7. That was again how it is tested, like 1, 4 from the bottom. Let us carry from the bottom onwards. 1, model 1. Suppose now again I'll say module 7, module 4, module 5, module 6, module 1, module 2, module 3. Now how they will interface? They will interface in module 1 to module 4, then module 2, module 5, module 3 with module 6. Okay, in 3 steps. Correct. Now in next level is 1, module 1 interface with module 4, interface with module 7. In this way, it's bottom up, and these interfaces are in bi-directional. Okay, this will not be in a top-down approach. This is bottom up, from down to up. Then 2, 5, 7, right? And then module 3, 6, 7. And in the end, what will happen? 1, 4, 7, 2, 5, 7, 3, 6, 7. Okay, so in this way, they're going to execute the interface. Now, another one is sandwich and big bang. Now, in a sandwich approach, like sandwich, not the bread, butter, or some veggies inside it, not the sandwich, not the eatable sandwich. This is in your software testing. Sandwich is a system that a system is integrated by using like top down and bottom up. Together, they are integrated. So there's a mix approach is used, and your system is built in a hierarchical way, consisting of your 3 layers. So bottom layer contains all the modules which is to be invoked, and this applied to the integrated in your bottom layer. Then the top layer modules implementing, creating a major decision to do or not, what decision to be made. So these modules are integrated by using your top-down approach, and in Big Bang, first all the modules are individually tested. So Big Bang sandwich, we have seen that all 2 approaches, all 2 methods are clubbed together. And now next, all these modules are put together to construct the entire system, which is tested as whole. Now what happens, I'll go back and see. So I'll just read out this. So in Big Bang approach, first all the modules, that means this has been done the unit test, it has gone through the unit test, and later all these modules are put together and they construct the entire system which is tested as whole. So sometimes developer use the Big Bang approach to integrate a small subsystem. So break the complex one. You need, suppose you're building a very major developing a project, you need to break it through. Make a small subsystems, make a small systems, and then you go through integration, regression, and every sort of testing which is required. Then you have a function testing. So functional during your requirement. So this sometimes this is treated as functional or non-functional. This is done in your requirement phase. So in functional testing, one does not have to internal details of a program, and the program is treated as black box. Now I don't know how many of you have remember black box testing. So in black box testing, what happens in a black box testing is that we don't want the code. We just only look into the requirements and we test those requirements with different approaches. What happens in functional testing? There are two types of functional testing and non-functional testing. So in functional, like what are the features that we need to be tested, that need to be tested. So as a test engineer, which is concerned only a programmer about the accessible outside the program, but we as a test engineer, you should also conduct a test on your requirements. So idea of structural testing. The first, like white box testing has been divided into two things like static and structural. So structural testing and functional testing does not give programmers and test engineer a choice of whether to design test cases from the source code or from the requirement. So this is very correct. Like as a test engineer, I don't have any options to look into the code from the white box testing code or black box testing code. White box is about testing your code specification. Let me clear with this. And white black box is about your requirement testing. Correct? Don't get mixed up with these two. These are two testing methodologies, and inside it you will see the testing technique. Now what happens is, as a test engineers, I don't have any choice to create my test cases from the source code or from the requirement specification. So function in max, how the function is defined in mathematical view. A function is defined to be a set of ordered pairs like x and y. So mm, xi is a vector of input values and yi is a vector of output values. So there are two terms used as an input vector and output vector, and there is a function which will, when the input is given, there is a function to make the transformation and give me the output. So let us see how that is written. So in functional testing, features are put into the test. A program P is viewed as a function that transforms the input vector, that means my x, into output. How my function is been written over there. My function has transformed my input to output. And what is that function? That function may be a piece of code, can be. So precisely identify. Now there are three key elements included. How the three elements are included? They are input, their output, and their functions. Precisely identify the domain of each input and output variable. Now is when we are writing about uh, when we are talking about the code or about application of the domain, we need to identify the domain inputs. Now, if I make a login module, so I need to understand what are the what names can I put and what could be the password, and whether to click submit buttons after filling the form like login or sign in form, like when you make your account on online, you have to go through certain procedures, like you have to fill up the form, then the OTP is given on your cell phone. You type that OTP and then you become a member or you purchase something and so on. So these are the functions that you perform on your cell phone or online shopping and so on. So this a domain values, like for the shopping details you need for domain, or for education, or for like hospital, bank, different types of domains are there. But you need to choose certain values from the domain area, not the entire thing, because your scope, your boundary to the project developing is defined. The boundary of it. So you need to understand your value, your data from that boundary. Okay. Now, select values from data domain. As I spoke about the domain, that application area, you need to define your data for each variable having a different property. So, consider combination of special values from different input domains to design test cases. So, there will be a special values. Now, these special values have different input domains to test cases. Then you have input values that the program under the test produces a spatial values from the domain of the output variables. This will be little difficult for you to understand, but you need to read on about this, because what happens is your domain, first you need to understand your domain and expertise area. Correct? The domain, if I talk about in very simple way, is about like education, banks, hospital, and so on. So these are the domains available. Now when, if suppose I'm making a form, a login form in a hospital domain, so I will choose the value. I will ask for the values like when is at, what is the patient name, date, what are the symptoms, when she's at, when he or she is admitted, when is the patient admitted, when the patient gets discharged, or what type of room the patient lived, and so on. Who was the doctor? What the doctor said? The name of the treatment, and so on. Name of the medicine. So we need the values from this domain. We don't need the values like school name, roll number, and all. Understood? So the domain values should be defined first. Don't get mixed up with the domain. Then you have to understand the set of input and set of output expected. First, you enter the input, transformed with the help of the functional, you transform the input to output and get those domain. So considering those input values, such as that program under the test produces special values from the domain of the output variables. Then you have, now what are the techniques? You understood the functional testing. Now what are the techniques, like how to do it? So they are the number of ways. These are the pairwise testing. You can do it. Then you have okay, let me explain you about the pairwise testing. Now, pairwise testing, that means each possible combination of value. It's like AB. Suppose the inputs are AB. For every pair of input value is covered by at least one of the test cases. That means you have to make your test cases first. Create your test cases. Then, uh, when you create your test cases, you need to identify what are your input variables for that test cases. So that means it should be paired like 2 or 3 values. So that means pairwise testing requires a subset of test cases vector covering all pairwise combinations of values instead of all possible combinations of value of a set. Then the pairwise is also referred as two-way testing or all-pair testing. So one can generate 3, 4 ways or four-way testing to uncover all combinations of value testing. So as all combination of value or more and more variables can come up, correct? Because you need to check your inputs, you need to check your outputs, right? So this function, if you put 4 variables as input, if you check 4, suppose 2, 3, 4 considered, to transform it into an output, your function is such a way the size of test suite grows rapidly. So that depends upon your input. Now your test case depends upon your input, your functions to make, to give you a output. Now I won't say it's a proper output or correct output, but you need to understand your test cases should take so much of the values. Then next is your acceptance testing. I hope you understood your functional testing. Then acceptance testing is when and how and why. Okay, the question again arises. So this acceptance testing is when they are used and when they are performed after change. So as I said, the change, when the change is comes up, regression testing has to come up. So acceptance testing is at user place. That means I have accepted the system as a customer representative of the customer. Like I'm a customer who has asked you, come on, now let's think about as customer and developer. I was a customer, I approached to you as you are the developer, and I've asked you to make a system for me. Correct? Now you made a system, you develop a system for me. Now from my side, I will send a representative. I'll send my manager as a customer, as a customer manager. He or she will, that manager will approach you and will test the system, that the system is accordingly what intention was built. or it was like something else, it's giving me something else output, or it was the expected output has not yet been met. So acceptance testing helps us to understand whether the customer wanted, what customer wanted has been built. Are we building the right product, or are we building something else? So the customer defines a set of test cases that will execute to qualify and accept the product. The customer defines, see, customer has to be in this a customer, if he or she, if the customer understands the technical way, so they will prepare certain test cases which will be executed to qualify and accept the product. So acceptance tests are written to execute a real life scenario. Then later, it helps the customer to determine whether or not to accept the system. So that means it helps the customer to determine whether or not to accept the system. Suppose this system is not built accordingly what I expected. I will just say this, that it is not accordingly to what I wanted. So then go for a change, undergo everything. Do the meeting, do the work, documentation work, build up the code, test the code, create scenarios, and so on. So customer generally reserves the right to refuse to take delivery if the test case acceptance do not pass. So sometimes it's difficult to understand what customer wants at some part. So what happens is, if customer, when you're ready with your product, when you're about to deliver, but before that, when customer operates the system at their level, at their site, at their environment, okay, at their site, what happens if they found that this is not what we actually wanted? So customer can refuse to accept this product, and then that huge queue starts. So always, whenever you develop, like you make your requirements, whenever you design it, just think that requirements of your customer, what customer expected, and when you design and what you develop and what you test is accordingly what was expected, what was talked about, what was written, and so on. So customer generally reserves the right to refuse. This never happens. In case if it is happens, then the loss is yours. It never happens actually, because we always take care what the customer wants. Then we have the acceptance criteria are of two types: of product and procedure. The product acceptance, that means during the requirement phase, each phase is associated with acceptance criteria. This means I will accept this, I will accept that, and so whenever now, again we are talking about the requirements engineering. Again, I'm saying this is not about the requirements engineering or software engineering. We are talking about software testing. Since the requirement plays an important role, it can go to the design level, it can go in a developing, or it can come in testing. The requirements we comes from now at this phase, the software testing phase. The requirements comes from the software developer. Now, the requirements is like coding. So, whenever there are changes to requirements, the acceptance criteria are modified and maintained. So, they need a proper documentation. They need to be alert that whenever there is a change, a small piece of change in your requirement, the entire things goes on changes. So these changes are requirement phase is, as mentioned earlier, that requirement phase is associated with acceptance criteria. So that means I've accepted what I wanted. So there are the changes to requirements, acceptance criteria modify and maintain. Then there's a procedure acceptance. Now acceptance criteria can be defined based on the procedure followed for delivery. So that means it is defined based on your procedure. User administration or troubleshooting. Now, user administration and troubleshooting documentation should be a part of release. So, whenever, as a customer, if I come up to pick up my order means my product. So, with the product, that means the CD is available, there's a user documentations available, there's a troubleshooting manual. So, that manual consists of help. What helps troubleshooting in case if my product is not working, my products get hang, or in case of it's give me improper output, what should I do before consulting as now as a customer? In case if I find something which is not working, I will look into the manual first before I inform the technician. There will be a helpline number. There will be a people who will be like, I have a mail ID, I have a cell number, I have this number. Then there is troubleshooting is there, the user documentation is there, and so on. So this is a big part when you collect your delivery from your software development industry. So there's a contract. It's also a contract basis. So that is the management part, the administrating part. We'll see in the later topic. Up till now, whatever the testing we have studied or we learned this, it's like how, when, and where, why. And the scenarios are explained to you. In the later section, we'll see something important. Till then, bye.